Good morning to all. I am Mohan, Department of Mathematics, Assistant Professor, SNS College of Engineering. Today we are going to discuss about the definition and properties. See, basically the orthogonal matrix. See, the orthogonal matrix is basically it will be a symmetric and repeated eigenvalues. So in this symmetric and eigenvalues, repeated eigenvalues will comes always that repeated eigenvalues there is three types of eigenvectors. So that eigenvectors will be going to the diagonalized. So in this eigenvector, see the square matrix, it is possible only on this square matrix is considering orthogonal if its transpose is equal to its inverse. So in this property ensure that the matrix preserves length and angle when applies to vectors. So here the key properties say that is definition, the determinant of the orthogonal matrix is either 1 or minus 1. See that the value of the determinant of an orthogonal matrix is either 1 or minus 1, and then the orthogonal matrices from a group under the matrix multiplication, under from the matrix multiplication. See, usually the definition of orthogonal matrix, it will be a basically that symmetric matrix and repeated eigenvalues, that will be always it will be orthogonal. See that orthogonal, it is proves as the x1 transpose x2 is equal to 0 and x2 transpose x3 is equal to 0, and then x3 plus x3 into x1 transpose is equal to 0. So always it will be a row and the column matrix, the next matrix of the column, it will be 0. So that determinant of the orthogonal matrix is either 1 or minus 1. In this orthogonal matrix from a group under matrix multiplication. See this orthogonal matrix from a group under matrix multiplication. It's a very important thing. See in this the product of two orthogonal matrices is also a orthogonal. That is the very important. We will take that orthogonal matrix and then we take the another orthogonal matrix. So both will be orthogonal matrix. Let we take A is orthogonal matrix and B is also a orthogonal matrix. The product of orthogonal matrix, that is A into B, that is also a orthogonal matrix. So here the orthogonal matrix, the product of two orthogonal matrices is also a orthogonal matrix. Then the next, the matrix of cos theta comma minus sin theta and sin theta cos theta is orthogonal for any angle theta. See the 2 by 2 matrix, right? It will be a 2 by 2 matrix. So first row of matrices cos theta and minus sin theta, second row of matrices in this sin theta into cos theta. So it will be a sin theta that the matrix cos theta minus sin theta and cos theta is orthogonal for any angle theta. That matrices represent a rotation of 2 dimensions, So in this definition, it will be a orthogonal, and the properties of this determinant of an orthogonal matrix is either 1 or minus 1. Then the product of two orthogonal, that is matrix, is also a orthogonal matrix. So in this orthogonal, see basic is orthogonal is set of vectors that are mutual orthogonal. That is, the mutual orthogonal is always a perpendicular. See, for example, x1 transpose x2, x2 transpose x1 and x1 transpose x3, that is the perpendicular of an unit length. This type of basis is essential of representing vector in a way that preserves distance and angles. So in this orthogonal matrix is an perpendicularly have the values, then x1 transpose x2, it will be 0, then x2 transpose x3, it is 0, and x3 transpose x1 is equal to 0. So here the value of is always a 0. So that it will be a perpendicular or orthogonal matrix. So that is the orthogonal matrix. So in this, basics is a very important to the orthogonal matrix. Thank you.